Welcome to Applied Hydraulics and Pneumatics. Today's topic is actuators. An actuator is a device that converts fluid power into mechanical force and motion. Cylinders, motors, and turbines are the most common types of actuating devices used in fluid power system. Fluid power linear actuators convert fluid power into linear motion. They consist of cylinders and pistons that allow them to harness the power produced by hydraulic fluid, gas, or differential air pressure setups. Multiple industries use fluid power linear actuators to control positioning system. Following are the usual components that are part of functioning of an actuator. First one is power source. This provides the energy input that is necessary to drive the actuator. These are often electric or fluid in nature in the industrial sectors. Power converter. The role of power converter is to supply power from the source to the actuator in accordance with the measurements set by the controller. Hydraulic proportional valves and electrical inverters are examples of power converters in the industrial system. Actuator is a device that converts supplied energy into mechanical force. Mechanical load, the energy converted by the actuator is usually used to make a mechanical device function. Mechanical load refers to this mechanical system that is being driven by an actuator. Controller ensures that the system functions seamlessly with appropriate input quantities and other set points decided by an operator. Actuators are output devices which convert energy from pressurized hydraulic oil or compressed air into required type of action or motion. In general, hydraulic or pneumatic systems are used for gripping and or moving operation in industry. These operations are carried out by using actuators. So it may be classified as a linear actuator. These devices convert hydraulic or pneumatic energy into linear motion. Next one is rotary actuators. These devices convert hydraulic or pneumatic energy into rotary motion. Third one is actuators to operate flow control valves. These are used to control the flow and the pressure of fluids such as gases, steam, or liquid. Here you can see this actuator, linear actuator. Here you can see that U cup was seal. Then this one is cylinder. Then piston rod. So then this is piston. Then after that this end cover. End cover this bush for say this piston rod. Then o-ring. So the main purpose is to so avoid leakage. So construction of hydraulic and pneumatic linear actuators are simpler. However, they differ at their operating pressure ranges. Typical pressure of hydraulic cylinder is about 100 bar and of pneumatic system is around 10 bar. These cylinders produce work in one direction of motion, hence they are named as single acting cylinders. Figure shows the construction of a single acting cylinder. The compressed air pushes the piston located in the cylindrical barrel, causing the desired motion. The return stroke takes place by action of a spring. Generally, spring is provided on broad side of the cylinder. Here you can see that double acting cylinder. So if you want to have an extension, supply oil from this side is connected to the reservoir. Suppose if we want to move this piston forward, oil must be supplied from this side, and this port is connected to the reservoir. Here also we can see that piston seal, piston, then oil seals, end seals. So all those things are there. So in a single acting cylinder, so this side, so the spring is provided with, so that so after say completing this forward stroke, then it will go back to its once the pressure is released, it will go back to its original position due to spring pressure. So in a double acting cylinder, the oil is supplied on both sides. So based on the direction, so you can move by supplying oil. Main parts of hydraulic double-acting cylinder are piston, piston rod, cylinder tube and end caps as shown in figure. The piston rod is connected to piston head and the other end extends out of the cylinder. The piston divides the cylinder into two chambers, namely rod end side and piston end side. The seals prevent the leakage of oil between these two chambers. The cylindrical tube is fitted with the end caps. Pressurized oil air enters the cylinder chamber through the ports provided. The rod end cover plate, a wiper seal is provided to prevent the leakage of oil and entry of contaminants into the cylinder. The combination of wiper seal, bearing and sealing ring is called cartridge assembly. The end caps may be attached to the tube by threaded connection, welded connection or tie rod connection. The piston seal prevents metal to metal contact and wear of piston head and the tube. So double acting cylinders may be provided with cushions. Cushioning arrangement avoids damage due to impact occurred when the fast moving piston is stopped by the end caps. Deceleration of piston starts when the tapered plunger enters the opening of the cap. So to safeguard this, only for safeguarding this component, so cushion may be provided so that at the end of this stroke it will move very slowly. So now for rotary actuators, so we have gear motor which converts energy of pressurized fluid into rotary motion. Rotary actuators are similar to electric motors but are run by or run on hydraulic or pneumatic power. It consists of two intermeshing gears inside a housing with one gear attached to the drive shaft. Figure shows the schematic diagram of gear motor. Air enters from the inlet, causes the rotation of meshing gear due to difference in pressure and produces the torque. The air exits from the exhaust exit from the exhaust port. Gear motors tend to leak at low speed, hence are generally used for medium speed application. Here you can see this gear motor. So you have a pump shaft, then drive this drive gear, driven gear. So then inlet, the outlet, all those things are there. So similarly, vane motors also there. So here you can see that shafts. Then you have slots inside which this so vanes move inside, in or out. So here you can see that uh, here volume is less. Then when the move at a different say angle, then here volume increases and finally delivered to the outlet. So it will basically change on volume. So it is this center and this center are not same or it is eccentrically mounted so that whatever the air or oil comes in and be transformed into mechanical power. Spur, helical and herringbone design gears are used in gear type motors. The operation of gear type motor is shown in figure. Both the gears are driven gears, however only one connected to the output shaft. As fluid under pressure enters the chamber, it takes path of least resistance and flows around the inside surface of the housing, forcing the gears to rotate as indicated. The flow continues through the outlet of port of the return. This rotary motion of the gear is transmitted through attached shaft to the work unit. So vane type motors as I shown earlier here. So this one is vane type motor. Typical vane type air motor is shown figure. This particular motor provides rotation in only one direction. Rotating element is slotted rotor which is mounted on drive shaft. Each slot of the rotor is fitted with freely sliding rectangular vane. The rotor and vanes are enclosed in the housing. Here in this figure, the rectangular vanes are here in this slot. so which can be moved out, and as well as, so at the maximum it can come this side, then minimum, so it can go completely inside. The rotor and vanes are enclosed in the housing, the inner surface of the which is offset from the drive shaft axis. When the rotor is in motion, the vanes tend to slide outward due to centrifugal force. The distance the vanes slide is limited by shape of the rotor housing. Thank you very much.